Welcome to Flight Safety Connection TV. My name is Marielle Michaeli. I work in the ATR Avionics System Design Office and specialize in performance-based navigation. I will be hosting today's broadcast with my colleague Quentin Faure from our Flight Operations Support Team. Welcome, Quentin.
Thanks, Marielle. In this second live broadcast, we'll focus on managing the approach safely. In particular, we want to focus on the existing technology, infrastructure, and pilot training that ensures the highest levels of safety for all approaches. And so, welcome to today's broadcast.
We are proud to say that our last broadcast gathered 600 participants from 50 countries. We received over 40 questions. One of the areas you ask ATR to improve is question management. This time, if you escape from the full screen, you will see a field where you can type your question live. Selected questions will be displayed on the screen and answered live. We commit to answer all questions either live or following the broadcast. Before introducing today's panel, let me update you with ATR's highlights for the start of the year 2021. We received FAA approval for the ATR 72-600 freighter, and our new aircraft will soon arrive in the USA. Commercial air traffic, in particular freight traffic, continues to grow. We have more than 800 aircraft now in operation. Of course, every day we see the ATR fleet transporting essential medical supplies in the regions. But I take the opportunity today to promote another great achievement I would like to share with you. Around 6% of the world's population suffer from hearing loss and wear hearing aids. These passengers could not participate in a full flying experience and in particular feel safe because they cannot correctly hear the public announcements. This is the reason why we are very proud to announce the introduction of AudioBack, the first standalone hearing aid loop concept in commercial aviation. And the safety of our passenger is the most important for us. With this in mind, let's come back to the focus of today's broadcast: how we can maintain the highest levels of safety in approach, taking advantage of technology and training. In fact, the distinct theme of our broadcast is managing every approach safely.
Thank you, Marielle. It's a great pleasure I introduce today's panel. First, Captain Hervé Barthes, ATR Head of Flight Crew Training.
Thank you, Quentin. Good morning, good afternoon, even good night sometimes due to the time zone. Well, it's a great pleasure to be back with you today, and I'm very looking forward to the Q&A question at the end. Thanks.
Thank you, Hervé. Captain Mathieu Olivier, flight test pilot.
Hi, Quentin. Hi, Marielle. I'm very pleased to be back with you here again. And today we have very good topics to discuss.
Thank you. And Géraud de Rivals-Mazer, Flight Safety Director.
Hello, good morning, Quentin and Marielle. I'm very pleased to be here as well because my role in ATR is to look for opportunities to further improve the safety of the operations. We know that the approach and landing are the phases of the flight where we have the most opportunities to improve safety. So I'm definitely looking forward to the discussions of today's panel and even more looking forward to the questions from the audience.
Thank you, Géraud. So, welcome everyone. When we refer to managing every approach safely, we want to focus on the procedures training, and the developing aircraft technology. But first, Jero, let's discuss the safety context.
Sure. So the reason why we have selected this topic today is that, as I said earlier, there is still a high rate of events in approach. If we refer, for instance, to the latest IATA annual safety report, which was issued last month only, according to this report, 2/3 of the accidents happened either in approach or in landing. If we refer now to the ICAO's 2020 annual report, on this report, more than half of all reported events are runway safety related, and 43% of all fatal accidents are runway safety related. I think that if we want to tackle this runway safety event, if we want to tackle abnormal runway contacts or runway excursion or even controlled flight into terrain, I think we need to focus on the approach. And now, if we look at these events in approach, they are usually linked to either descent below minima, or flight below the profile, or no go around after the approach is unstabilized, or loss of visual reference, for instance. So today, the goal of this panel is to clearly state that when we have the technology, when we have all the procedures, when we have the training, we can tackle these events. So let's start now the discussion, and let's start maybe with the basics. So Quentin, could you please tell us, from your point of view, what is the typical approach of an ATR flying in some country in the world?
Yeah, that's a really interesting question. In fact, basically, there are two building blocks, visual and instrumentation. Of course, Instrument Landing System, ILS, is typical in all major hubs. But our aircraft operate as well remote airfields. Therefore, you are using various solutions every day, depending on the constraints of each airport, such as technical or operational, and on traditional habits. You can fly a VFR, so Visual Flight Rules approach, when you meet the visual meteorological conditions, VMC. Consisting visibility plus distance from clouds and obstacle clearance. You don't need any guidance from instruments because it is based on external references. On the other hand, instrumented approach allows you to fly when visual meteorological conditions are not met. But you need references from flight deck instruments based on a published procedure. Evidently, technology associated with instrumentation has greatly changed over the same time. This change significantly improves accessibility into all airfields.
Yeah, sorry, Quentin, if I may jump in at this point. We could actually stop the discussion there. Today's existing rules are clear and have been for decades. We are all trained in the same way, knowing these very simple principles. Don't you think, Mathieu?
I fully agree, Hervé. So we need to keep this in mind as we go deeper into today's technology. So when I reflect on Jero's safety context, there are two concepts. Maximizing your operation, let's say lower minima, obstacle clearance, etc. But at all times, keeping or improving the safety margins. About the controlled flight into terrain events called CFIT. In our industry, there are violations of the basic rules. But you can also see flight crews being trapped through lack of standardization, decision, or lack of decision not using the technology that is available. Let me be a little bit provocative. This discussion would also be a lot shorter if we had published charts for all the commercial flights on airfields that we operate.
Hervé, can you share with the audience what you told me about the use of the FMS?
Sure, Marielle. in all circumstances, and this is our first important key message today, do use your FMS to develop your standardization, to improve situational awareness and reduce the workload, the two topics being linked anyway, to assist decision-making, generally speaking, and more precisely at specific point in the approach. Let me detail a bit how you can optimize your FMS usage. Of course, there is more and more PBN approaches published today. But you should use it also to operate conventional, non-precision approach, I would say, such as VOR, NDBs, etc. The ATR is fully certified to use the FMS to fly these approaches. Just make sure you still refer to the relevant chart and associated minima, and keep a needle somewhere in the cockpit with the relevant VOR or NDB reference. But you fly, probably through the autopilot, the FMS track. And if you are equipped with the VNAV mode, that gives you a 3D approach. So isn't it bad? I mean, this is great. You are flying a 3D approach with the NDB support. Now, let's make sure you don't use the FMS as a substitute to the PBN. What I mean is that we should not use it to replace the normal tendency to move on to the PBN direction. What I mean is the RNAV and GPS-based approach.
Hervé, you just explained that each pilot should use FMS to fly either a VOR or NDB or ANP approach. There is a question that we have received prior to this broadcast, and it's the opportunity for me to remind you all that you can post your questions live. So we thank you in advance for these questions. Let me read this question for you. Will automatic navigation source switching be available on the next avionics standards? Maybe, Marielle, you could answer this question?
Actually, yes, this is under development. But maybe you can, Mathieu, you can have a word as you are currently testing it?
Yes, for sure, Marielle. These evolutions are currently under test, and I can tell you that they will bring great enhancements in crew workload, for example, and benefits for standardization.
Okay, thanks for this answer. Hervé, you just mentioned as well the 3D approach. Maybe Quentin, could you please explain the concept of the 2D versus 3D design of the approach?
Yes, for sure. So the approaches designed in 2 dimensions, I mean longitudinal and lateral, pick up the highest obstacle during the whole approach. We add a margin on top of that to calculate the minimum altitude where you need to have the runway in sight, your minima. 3D approaches, meaning longitudinal, lateral, and now vertical, look for the obstacles within the given prescribed corridor. You can usually fly at lower minima and therefore have better terrain accessibility.
Okay, clear. Now maybe could you please explain what the RNP approaches are?
Yeah, for sure. So first of all, what are the steps to use this technology? In fact, it's based on 4 pillars. First, your aircraft is approved. That's our duty, that's the ATR duty. The airspace requires PBN. The pilots need to be PBN trained, and the operators establish PBN SOPs, SOPs for standard operating procedures. We will support you. So feel free to ask should you have any question on that. So now, about your question. Let's describe the RNP approaches. The first one, LNAV. LNAV stands for lateral navigation. So the guidance is in fact the capacity to navigate from waypoint to waypoint in 2 dimensions. This is provided by GNSS, so Global Navigation Satellite System source. The design of a LNAV, by definition, does not include a vertical guidance. Now let's describe two approaches with vertical guidance, which are appropriately named APV. The first one with barometric reference, called LNAV-VNAV, and the second one with satellite-based augmentation system, so SBAS, called LPV. So, on top of LNAV capability, LNAV-VNAV, which is also called baro-VNAV, uses barometric altitude for the vertical guidance. Temperature compensation is available. This 3D approach allows the autopilot to be coupled to the flight profile computed by the system.
Okay, so now let's have a look at the technology. Marielle, can you explain how to have this technology?
Let me start with LNAV. The Flight Management System, FMS, builds a lateral trajectory. This is defined in the navigation database. And based on your Global Navigation Satellite System, GNSS position, the autopilot maintains the aircraft on the lateral trajectory. For baro-VNAV, the reference for vertical positioning is the barometric data provided by Air Data Computers, ADC. And as for lateral, based on the computation of the descent slope and rate by the FMS, the AP maintains the aircraft on the vertical profile. Mathieu, maybe you can explain to our operator some specificities of baro-VNAV coupled with the autopilot solution compared to VNAV advisory?
Sure, Marielle. Baro-VNAV on the ATR offers multiple alerts to the crew when the VNAV mode is engaged. Let's take two examples. First one, the vertical path change alert. This one intends to alert the crew that the aircraft pitch will change due to a change in the VNAV guidance. The second one, the vertical track alert. This one targets at alerting that the alt cell, or altitude selection knob, should be modified if the crew wants to keep on following the FMS flight plan.
Marielle, we understand from what you said earlier that our systems are capable of baro-VNAV. What do I have to do on my aircraft to have actually this system on board?
Let me demystify the installation of VNAV capability. First, you need to update the flight guidance control panel with the VNAV push button if not already done. Most of the 600 have it. Then, you update your aircraft configuration to activate the VNAV option. Nothing could be easier. You go in the deck with your memory card. The card is the one you use in launch to update your navigation database. Insert it in each display unit, restart the display unit, and your aircraft configuration is now updated with VNAV capability. I am focusing on the later generation aircraft, but I insist that solutions are available either through ATR or an STC.
Okay, clear. So the technology is there, available on the aircraft. As an operator, why would I want to use it? There are many reasons, of course, but maybe the first one is safety. LNAV mode means that the FMS is in charge of the lateral guidance. As explained earlier, whether you fly a VOR, a NDB, or even an RNP approach, you would fly it exactly the same way. This brings great standardization benefits. Now, on top of it, if you include vertical navigation, VNAV, then the FMS would optimize the vertical profile for you. Again, whether you fly a VOR, NDB, or RNP approach, you would again fly it exactly the same way, so that's great standardization benefits for the pilots.
Exactly, Joe. From a pilot's perspective, it is really comfortable to fly every approach in the same way. You would save a lot of workload with a unique approach standard. I remember when I started my career, the workload flying a VOR or even worse, an NDB approach was high. Today, these approaches are all flown in the same way, with a vertical guidance. Can you imagine the steps we have made? All this for the benefit of safety. So again, let's use the available technology.
Yeah, talking about technology, let's continue with the RNP description. So, with second APV concept, which is called LPV, which stands for Localizer Performance with Vertical Guidance. It relies on a satellite-based augmentation system, SBAS, that enhances the precision of the GNSS signal. Please note that the SBAS coverage is currently limited to specific zones of the planet, but it is evolving to larger zones. LPV capability has several advantages compared to LNAV-VNAV approaches. This means better minima, close to ILS category 1, so almost down to 200 feet. In addition, the precision gets higher as the aircraft gets closer to the airport.
Again, let me explain this from a system point of view. Since the approval of NAS Standard 2, our GPS is capable of SBAS, which means correction of signal measurement error. This allows to reduce spacing between trajectories and to enhance the existing aircraft capabilities, such as RNP-AR. But I insist on the term enhance, because SBAS is not a prerequisite for this capability. GPS SBAS positioning is available on all flight phases. For LPV capability, you need two of them. LPV has been designed as an ILS lookalike. At 2 nautical miles before entering the final approach, the guidance source is the GPS and no longer the FMS for the display and the monitoring of the lateral and vertical deviation. Again, solutions are available for later generation aircraft. I confirm you today that an STC is available for aircraft equipped with HT1000.
Marielle, you just explained that LPV is ILS-like, and this is the benefit I want to highlight here. LPV approaches, as for the ILS approaches, are ground-based trajectory, even vertically, as opposed to the LNAV, VNAV approaches, which depend on the atmospheric conditions.
I think this answers to a question that I will read now, that again we received. So most of RNP approaches are not confirmed with PAPI. Please let us know the reason why.
Yes, that is true. The vertical guidance of LNAV, VNAV approaches comes from the barometric altitude, and therefore the PAPI will not always confirm the vertical path, as opposed to the LPV approach, which vertical guidance is provided by the GPS. So now you can see the options for your operation increasing. LNAV, LNAV, VNAV, LPVs. And by the way, Marielle, what about RNP-AR? From what I know, you are the one actually designed the system.
I could speak about it for hours. RNP-AR stands for Required Navigation Performance with Authorization Required. It's a big word to remind you to apply the 4 pillars explained by Quentin earlier. RNP-AR operation used reduced obstacle clearance margins that make it possible to implement approach procedures in situations where other procedures are not operationally feasible or acceptable. It is used to environmental constraints as nose abatement and mountainous areas, but also to optimize your trajectory for fuel consumption reduction, for example. Compared to the standard RNP approach procedures, the solution that we propose to our operator for ATR 600 aircraft offers additional onboard monitoring and alerting thanks to a dual-channel architecture. Pilot flying and pilot monitoring use their own navigation sensor and guidance computers, similar as the one you know for ILS Cat 2. We recommend you to use your autopilot during the procedure. An inertial reference system, IRS, is installed in addition of the two attitude and heading reference system, AHRS, and uses as a backup navigation means in the case of GPS signal loss during the operation. But let's be clear. I agree that the investment is significant. But for the cases I mentioned before, because I was deeply involved in the system design of the capability for 3 great years, and I have seen the use, the operators they have it, I can assure you that the benefits are huge.
Yes, and you need to ensure that the pilots are comfortable with it and proactively decide the level of automation you want to use for your operation that matches your standard operating procedures, the SOPs. Well, no surprise, of course, that I want to highlight the training aspects. And by the way, not only for the RNPAR. Know your system and the automation. Train your crews to use it properly and according to the developed SOPs. As we already said, you must standardize your operations and have a clear strategy for each airfield and approach, which is part of your airline policy.
Hervé, Mathieu, how do we do that? How do we integrate the onboard technology with procedures and training?
May I try an answer, Marielle, Hervé?
Please, Mathieu.
So how do we go from today to maximizing our safety margins tomorrow? The message here again is standardization and adherence to SOPs. But to increase access to airfields, reduce crew workload, maximize aircraft performance or reduce the fuel burn and carbon footprint, we can definitely move to the 3D approaches. In summary, approach design, approach validation, escape paths, validation on the full flight simulator, integration within your SOPs, monitor on flight data monitoring, adapt your SOPs, standardize.
Yes, and please never stop training. You know, we still have examples today of questions raised showing that crews are obviously training to use typically the VNAV push button using the trial and error method, and with passengers. This demonstrates the clear need for training.
Okay, so maybe let me recap the discussion so far. The first key message which was given by Hervé is do use your FMS. But of course you need to keep in mind that you need to know your automation, you need to pay attention to the training and to adapt your SOPs. Now the second key message is about standardization. Whether you fly a VOR, a NDB or an RNP approach, you will fly it exactly the same way. So the benefits now of the RNP approaches are clear, well understood, which brings me to another question. Can ANSP, Air Navigation Service Provider, design RNP approach at VFR airport, or are there any restrictions? If yes, what could be the minima? Maybe, Quentin, you could answer this question, please?
Yeah, I can. So, in fact, the question is to go from visual to instrumentation approach. To publish an instrumented approach, so including for sure the RNP, the airport needs to be IFR. But as I explained earlier, thanks to the RNP approach, you don't need to invest in costly ground navigation aids. The question you need to have is, what level of instrumentation do you need? For sure, as the minima are depending on the RNP approach that will be implemented.
But Quentin, I want to insist on the fact that you need to know your automations at all times. Situational awareness remains a key part of a successful approach. This includes, for example, comments from the last broadcast about threat and error management. And when the aircraft does not respond as you expect, take over. Develop your what-if strategies.
Yeah, I fully agree, Mathieu, there. We can provide PBN courses, and specifically the VNAV, either as individual training or train the trainer module, which is, by the way, our most preferred option, as it brings the knowledge and skill within the airline, providing experts to work on airline crew training and training programs, SOPs, manual, but also to discuss with the authority for new possible approach design. Now, something, we have not discussed the monitored approach. We know a number of customers use this type of procedure. This is not something that ATR promotes. But, as with everything, there are pros and cons. Let's say the debate is open.
Okay, so debate is open means that please do not hesitate to post questions if you want us to discuss about this topic. I would like now to read another question received. In approach for a VFR airfield without IFR procedure, does ATR recommend MCDU inputs in order to improve the final segment? Maybe Mathieu.
Yes, Joe. The FMS can be very useful to follow a safe final approach path, even on a VFR flight. For instance, in the arrival page, the pilot can select the runway in use, no other arrival input, then perform a direct to inbound course on the threshold. Doing this will result in the display of the final approach axis. On top, if the aircraft is equipped with the VNAV capability, then the final approach can be performed on a standardized 3-dimension trajectory. At any time, the crew would be aware of any deviation to the optimal flight path and be ready to react accordingly. This brings great safety benefits. But keep in mind that VFR rules must be met at all times. Regarding the situational awareness, I take this opportunity to highlight other developing technologies that include enhanced primary displays. These systems can give an illustration of the terrain ahead, even in the clouds or in heavy rain. Let me take the example of the Enhanced Vision System, EVS, Clear Vision. It offers the ability to develop further operational flexibility. It was certified last year and provides significant operational benefits whenever you operate in airfields with often low visibility.
Mathieu, you mentioned earlier that there are two concepts. Maximizing your operation, lower minima, obstacle clearance, but all time keeping or improving the safety margin. With all the technology already on the aircraft, I think we need to highlight we are here to assist operators. From my perspective, as a system design specialist, it seems a pity not to use this technology to assist pilots and airline operation. Could I ask, what do we consider to be the blockers of obstacle?
That's a very good question. As we said, technology is there, the training is available, the procedures are there, so what are the blockers? If we come back to the initial expansion of the commercial aviation, we had as well the expansion of the ground navigation aids. Now that the expansion of the regional aviation is there, with operation to some remote airports, for instance, we don't see these ground navigation aids expand. However, as we already explained, we don't need anymore these ground navigation aids, which is good news. When you want to design RNP approach, you don't need this. So what are the blockers to have these approach designed? You need a lot of stakeholders to have this approach designed. You need people from design itself, of course, from the authorities, the operators. All these stakeholders need to agree on how to design this approach. So that's one possible blocker. Another blocker, of course, is the money. You need money and you need time to have this design available. But I want to be clear here. This is far less expensive to design this approach compared to the purchase or even the maintenance of heavy ground navigation aids. We have launched a number of projects in cooperation with ICAO or EASA and local authorities, for instance, in Colombia, in Guapi, in Indonesia. The safety benefits of the design of the 3D approaches in remote airport is unquestionable. Not to mention as well, as already discussed, the fuel burn savings and associated environmental benefits.
Yes, Joe, and let me insist, without realistic standard operating procedures, the SOPs, flight crew are taking risk, being mission focused. And these SOPs can adapt from the flight data monitoring. We encourage every operator to run a flight data monitoring program, learn from their operation, and adapt consequently their SOPs. Let's be clear. From our perspective, the safety issue or challenge comes from the commercial pressure. So let's try to summarize our operational recommendation. Maybe Mathieu, you want to start?
Yes, let's start with IFR approach. In IFR, use the FMS 3D capabilities or the ALS. So in the short term, consider that the FMS is a good tool to create all the conditions for a safe approach and landing, improving stabilization and situation awareness through standardized procedures.
Right, and let's go for on the VFR side now. In order to reach VFR airport, the strategy could be divided. First, let's say a long-term strategy, which is designing IFR approaches. We're talking about PBN approach, of course. And this is definitively the most important point, one of our key messages today. That will provide the best benefit and the highest level of safety. Now, during this development phase, we could think about a mid-term strategy, which is about the visual RNAV. There are ongoing discussions with regulation at this time. Once again, there is pros and cons, but what is important is make sure today you don't start with such operation before it is well defined and validated by the authority. Now, for the very short-term strategy, what you are already doing every day, and which is flying VFR to this terrain or handing a IFR flight with a VFR approach. The FMS is a good help for such operation. A positive usage of the FMS is, for example, to create a VFR key point, as mentioned previously by Mathieu, and then it becomes the new crew objective instead of targeting the runway threshold. You now have a very standardized operation. Your VFR approach almost look like an instruments approach. And you have created the best condition for a stabilized approach, which is, we all agree, the best option for a successful landing. The last point, and I want to insist on that, in this case, flying VFR, you must comply with the VFR rules.
Okay, thank you, captains, for this good recap. I think we have reached the end of this discussion among us. So let's now go through the questions that we have received. There is a first question, which is, hi ATR, going forward with further development in the FMS, would ATR be looking to have similar concept as an Airbus FMGS? Actually, I would dare to say that our system is already pretty good, and and to be compared with FMGS, I would like to know your point of view, because I think you know pretty well this system as well.
Yes, I know the Airbus system too, but to answer the question, no. There are no development ongoing or discussion to have a coupled system to integrate FMS in FMGS today. We are very happy with our architecture, but if you have any comment on it, please do not hesitate to share with us.
To further explain what you already had in mind.
Just Jérôme, maybe
Yes.
a few words on this, because from the pilot's perspective, let's say what we need is a system that guides you to your goal, which is a stabilized approach for a safe landing. In that frame, it is obvious that our system using AirNav, LNAV, VNAV, LPV or ILS approaches are very good to fly these safe approaches. And no matter if it is directly integrated as Airbus does, Airbus system are very good systems. But here in our ATR system, it doesn't work in the same way, but the goal and the result in the end is the same.
Yeah, great.
Okay, thanks. So maybe we have another question coming on the screen. What is your opinion to increase the rate of abandoning destabilized approaches? How do we do to increase this rate?
Well, we have worked on that for many years in the training center. There is a panel of solution, and actually it's the mix of everything which will create the proper context. Having proper, well-written SOPs, well-trained, will decrease the level of violation, for example. CDLS, constant descent approach, is another key factor to get stabilized approach. Standardizing, as we were mentioning previously, standardizing all the approaches is also helping the crew, lowering the workload, then maximizing the situational awareness, and all these has consequences on the rest, including the stabilized approach. Well, I would say, on top of everything, train, and make sure that there is no open door and do not accept any violation on the unstabilized approach.
Okay, you want to add something, Mathieu?
Yeah, Hervé, you have mentioned the VFR key points during this conference, and I would like to take this concept here again. This is a key point to improve the decision making during an approach. This operator was talking about abundant approach based on stabilization criteria. To me, this is a good tool to force the decision making. Is in fact to know at all times, to know where you are in comparison with an optimal flight path. If you create this, let's say, key point, then you would know at all times where you are compared to this optimal flight path. And then the decision making, in terms of going around or not, is really eased in that situation.
And if I may, take the opportunity to keep on going and added a few key messages. We have discussed previously the threat and error management, the importance of briefing. Let's say another possibility to make it even better, using the TEM included in the briefing before the approach, and for a briefing, even for a VFR approach. If the crew is well prepared, thanks to this briefing, well prepared to the go-around phase, then it will be much easier to do it in case of an unstabilized approach.
Okay, thanks for these answers regarding the unstabilized approach. Hervé, you mentioned earlier the VFR strategy, VFR approach strategy with short-term, mid-term, long-term strategy, and you insisted a lot on the training, of course, especially as head of training. This new question, for visual approaches, is there a need to follow strictly the published trained profiles from the FCOM, or they can be performed randomly?
Of course, FCOM is a guidance, is a help that we provide, and if it is the result of people have been working with engineers and built strategy and SOPs, and it is very interesting. It could be the basis of what you could build in your own company, airline, and state as your own SOPs, as it needs to have your proper needs and necessary specificity, maybe. I'm not too sure about what is if they can perform randomly. I'm not happy with the random idea of flying an aircraft or preparing an approach. So I would definitely say anything about performing random operation does not match. But you can adjust the FCOM. This is.
I agree. Random doesn't match our second key message about standardization.
Definitely.
Standardization and random, they don't get along.
Sorry, Jérôme, may I insist on this? I fully agree, Hervé. Random is a word we don't really like for the approach. But coming back on the VFR key point we've talked about previously, this key message would allow you to know at all times where you are compared to the optimal flight path, to the briefed flight path. So it's not the concept of random, it's just a concept of know where you are compared to where you want to be.
Okay, thanks. We have another interesting question here. We kept talking about the standardization, whether you fly a VOR approach, NDB, RNP approach, you fly it exactly the same way. This new question is, can we perform an NDB approach using FMS even if the NDB beacon is not operative?
Of course not, I would say, because yes, it is very comfortable to use the FMS to fly an NDB approach, but then the NDB approach must be the or one of the accessible approach that day. If the NDB beacon is not working, then there is maybe a NOTAM or something. It cannot be used to land the aircraft.
Okay, thank you. Another question maybe that we received. What is ATR recommendation regarding AirNav visual approaches? I know that there are ongoing discussions. Regulation is not yet there. I'm aware, for instance, of the discussions within the flight ops panel of ICAO. There are, as I said, ongoing discussions, pros and cons, a little bit like the monitor approaches. What is your point of view?
Well, as we said, it's interesting for sure. As also the ATR is very often used in very remote places, and factually, we know today that it is used to VFR airport. Why not thinking about it as a positive outcome? Now, and that's what I said previously, let's make sure we wait for this concept to be clearly defined and validated before we start to invent something, So it might be a mid-term strategy, but remain focused that the most interesting way is to create a real instrument, PBN approach.
This I fully agree, and this is why we have launched, as I said earlier, a number of projects in cooperation with ICAO and EASA. I just learned yesterday that this cooperation project with Colombia, for instance, this GUAPI approach will be available on the Colombian AIP early May. So this is improving, which is good. So now another question here. We mentioned several times, I think it was you, Mathieu, who mentioned the fuel benefits in using PBN. Can we assess? Can we have a quotation of these fuel benefits?
Yes, if I may start. Using PBN, in fact, will standardize for example, the arrival trajectories. So first, you would know at each flight what is your fuel consumption. And normally there would not be a great scatter between all the flights. So this is the first advantage. Second one, if you add on top of the PBN the vertical navigation concept, then you would save a lot of fuel. I don't have the figures in mind, maybe someone has them.
Yes, in fact, ATR determined that it's almost 20 kilograms saving for each approach with the VNAV engaged, and it's almost 2 minutes savings thanks to shortcuts. So that's huge, and when we are summing up all these benefits at the end of the year, that's huge in terms of fuel consumption and environmental advantages.
You're right, and I had the same rough order of magnitude for these numbers. And for instance, when you mention 2 minutes reduction in the flight duration, this means, of course, reduction in the fuel burn, but as well reduction in the direct maintenance cost. So the other quotation that we could give is $20 per flight reduction. So as you said, it's maybe not a lot for one flight, but if you multiply by many flights, that starts to be a good number.
Well, what is nice, Jérôme, is that I remember a few years ago, this topic started with very detailed and precise computation done by engineer side, marketing, I would say, this benefit. And today we start to have the feedback of people using it, and it matches the original expectation. And even in ATR, I know that, for example, we have discussed that, and Mathieu is a strong advocate of the using the PBN usage that gets benefit on the fuel.
Yeah, true. We also have benefits from the standardization perspective. We have benefits from the ATC perspective as well, as the aircraft, the flow of aircraft inbound an airport can be enhanced for sure. So, and finally, the safety benefits.
Okay. I think we have time for one last question, which is, does ATR promote continuous descent from the top of descent?
Maybe I can
I think
start
we have
with this
answered
one.
already this question.
We are advocating this method since the early days. It has been years now that we have integrated in our manuals and training and SOPs the constant descent. And by the way, the FMS is using this strategy as well. The FMS is making a constant descent according to the different constraints it may have for the descent and for the approach itself. And the last point is, we were just before talking about stabilized approach. This is the best way to have a stabilized approach. So yes, definitely triple times yes, we are pro CDLS.
What is, from your point of view, the benefit to retrofit from standard 1 to standard 3? Should we do it? So that's a question from the operator. So maybe we can explain the technology, and we will have the answer during the explanation.
As a system design, yes, I recommend you to retrofit from standard 1 to standard 3. And the reason, I will explain it just after, is the introduction of the PBN capability available since the standard 2.
Will the FCTM standard 3 be available, the flight crew training manual?
Well, yes, of course, we are always following the standards and the last options, the last standards with the training, the program, and our specific documentation within the training center, which is the FCTM. So I have no specific date to give you today, but I mean the last issue of the FCTM is quite up to date to the aircraft we have today, and it will continue to evolve and be updated.
Could you please explain the alarms that might come up to pilots when the GPS signal is lost, either from the deck or from the system?
As you want, Hervé, I could take it.
I mean, yes, please, go ahead.
Yes. So in basic configuration, you have since the standard 2 new caution that announce the GPS loss, GPS 1, GPS 2 is your configure 4, or GPS total loss. And this is basic for the configuration with standard 3. With standard 2, only the aircraft equipped with LPV and RNPIR have it. But I insist, in standard 2, this is the basic configuration. And in the particular case of LPV and RNPR operation, you have specific alerting due to, as I said, the reduced obstacle margins you have in this operation. As I can mention maybe the GPS disagree alerts in RNPR if you have a difference more than 50 meters between the two GPS positions. So to answer the question, yes, there is alerting relative to GPS loss signal, and even in specific operation if there is difference between GPS position.
Descent initiation is very abrupt when VNAV is engaged. Will these be corrected in the next avionics standards? Maybe you can...
Maybe I can start with the beginning of answer. So, well, actually, I thank you very much, the author of this question, because it is very related to what we are trying to highlight. Please train the crew to specific modes or options. And if the crew is not well trained and prepared, it might, at a certain phase of flight, create this kind of behavior. Well, this being said, it is true that there is still some transitions that might not be very comfortable, and well, we are still open, of course, as we always say, to feedback, and then with the help of the engineering side, and Marielle is the best one to confirm that maybe we can even improve furthermore the system.
For sure, we are aware of situation where the transition is not smooth for the operator and the passenger, please share your feedback with us and we will try to put in place a solution. But I insist that we work hard on the smooth transition during the development of VNAV capability, but maybe it's not robust to all cases encountered by our operator.
If I may, Joe, the way I understand the question is sometimes crew delay their descent or anticipate it. So sometimes the aircraft is above the optimal flight path, vertical flight path. And the way the VNAV mode has been designed is on the initial part of the descent, the vertical nav mode will guide you on a 5.5 flight path angle, if my memory is okay, down to the optimal flight path. So this could generate, for sure, a start of descent a bit sharp. But this joins the discussion we had before, because we are working hard on this kind of situation between design office, safety, training center and flight test to enhance this situation. And this is where the vertical direct-to option is a very, very good tool to realign the actual flight path with the desired flight path, and to avoid this kind of situation for sure, and to enhance the situation awareness. I mean, at any time, the pilot should know what the machine is going to do and where he is compared to where he wants to be.
So I think that closes our panel today. So my thanks to everyone for watching today's broadcast. Our key messages today are: 1. Take advantage of the technology on the aircraft. 2. Standardize your approaches. 3. Apply the rules and incorporate them into your SOPs. 4. Monitor and adapt based on your flight data monitoring feedback, of course. We are here to help. We can help you to design the approach. We can help you to standardize the approach in line with the automation, of course. We hope that we have demonstrated that you can use the technology available on the aircraft in order to optimize your approaches. We hope that you will be motivated enough to use this technology and to work with your authorities to maximize safety. I want to repeat that we are here to help, but it will take a collective effort in regard to training and approach approval to ensure we improve the industry record and we further improve safety. We have received a good number of questions. I believe it's not a competition, but compared to this morning, even greater number of questions. So thanks to all for all these questions and these proactive in-distance discussions, which was good. We will respond to all these questions, the one that we have not yet answered. My thanks, of course, to our panel today, Marielle, Quentin, Hervé and Mathieu. All the questions will be answered in our ATR Flight Safety website. Stay tuned. And the next broadcast is for September the 30th. So on behalf of ATR, thanks again for watching today and stay in contact for more ATR Flight Safety TV.